All right, now on to the third video. We'll do subtraction of polynomials in this one. Again, there's nothing new here. You've done this over and over and over. The biggest mistake is just forgetting to distribute the negative. When we were doing addition, we just dropped the parentheses. Here we can't just drop them. We dropped them before because there was nothing to distribute, but now we do have something to distribute. So you can actually do all these on your own. Take a break, work all of them on your own, and then we'll come back and do them together. Okay, now that you're back, let's look at this first one. I need to distribute that negative all the way through the second set of parentheses. So everybody seems to remember to make the 3k squared negative, but a lot of people forget to change the sign on the 6k and on the 2. So make sure that you're distributing that negative. Now what terms do I have that are like terms? Okay, my k squared and negative 3k squared, those are like terms. My 2k and my 6k are like terms. And my 1 and negative 2 are like terms. So if I rewrote it just to get like terms together, you don't need to, but if it's helpful, then do it. Then k squared minus 3k squared, that'll give me negative 2k squared. Remember, my exponent doesn't change. 2k and 6k will give me 8k, and 1 minus 2 will give me negative 1. When I'm combining like terms, my exponents stay the same. Okay, here's the next one. Distribute the negative. Okay, what like terms do I have? Good, I've got an a squared and a negative 4a squared. Those guys are like terms. Anybody else? The 2ab and the ab, they have the same variable part, so they are like terms. My a squared minus 4a squared, that would be negative 3a squared. The 2ab plus ab, that ab is just like a 1ab, so it can be 3ab, and then my minus 3b squared on the end. Now look at that for a minute and tell me if it's in descending order. It is. It's in descending order according to a, because the first term has 2 a's, the next term has 1 a, and the last term doesn't have any a's at all. I could completely flip-flop the order, write it completely backwards, and it would be in descending order according to b. Either one is fine. Just pick a variable and write it in descending order according to that variable. Okay, here's the next one. It's not hard. It may be long, but it's not hard. Just remember to distribute your negative. That's our first step. You make the 12x squared negative, but don't forget to change the signs on the other things in that set of parentheses. Okay, now let's go on a like term hunt. So we have 3xy squared. Are there any more xy squareds? Yes, there's another 3xy squared. All right. On for the next one, 4x squared. And there's a negative 12x squared. Okay, and then the y squared, there's another y squared. So if we rewrite it just so I get like terms together, then I'd have 6xy squared. Again, I'm combining the numbers, but I'm not changing the variables. Minus 8x squared minus 2y squared minus 5x squared y. Now this one's kind of funny. I've not written this in descending order. If you've got more than one variable, I'm not going to be picky about it, but when you do have one variable, you need to make sure you write it in descending order. Okay, this last one, remember to distribute the negative through that middle set of parentheses, but not to the third set of parentheses, only to the middle set. So I rewrite it without the parentheses, making sure I distribute any negatives that I might have. Now we go on a like term hunt. So let's look for all the x cubes. I have a 2.1x cubed, a minus 1.7x cubed, a minus 0.4x cubed. So I put all my x cubes together. Now let's look for all the x squareds. The negative 4.2x squared and the 6.2x squared. Okay, now for the x's, I only have that one x, and then I put my numbers at the end. I'm just going to collect the terms in order of in descending order so that I've already got them that way. Again, remember that you cannot clear decimals. You can only clear decimals or fractions when you have two sides of an equation. We only have an expression. We don't have an equation, so we can't clear decimals or fractions. Okay, you're welcome to use a calculator, but you shouldn't need one. 2.1 minus 1.7 leaves you with 0.4, and 0.4 minus 0.4 is just 0. So if we look at the x cubed part, that'll just be 0. If we look at the x squared, I'll get 2. Then I'll just have my x, and then all my numbers together will give me 0.9. So we have 2x squared plus x plus 0.9. You do not need to do all of those steps, but I do need at least one, possibly two intermediate steps there. You just don't need 4. Unless you want 4, and then that's fine. So that is subtracting polynomials. I don't think there's another example, but we will do multiplying next.